This is video 5, ME 210, Mechanics of Rigid Bodies by Oscar Guillen, and I have chosen to cover conservation of energy. For the conservation of energy problem is a pulley system is used to lower the hook down into the water, as shown on the right. The spool has a mass of 45 kilograms, a radius of 1 meter, and has a radius of gyration equal to 1.2 meters. If the 30-kilogram hook is released from rest and descends 3 meters, what will be its velocity? On the right, we have a picture of the situation, the pulley connected to the hook. Our given information is taken directly from the problem. The radius of the spool is 1 meter. Its mass is 45 kilograms, and its radius of gyration is 1.2 meters. For the hook, its mass is 30 kilograms, and then we can assume that gravity is equal to 9.81 meters per second squared. So to solve this problem, we can use the conservation of energy equation. Initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. So to solve this problem, we start off first with kinetic energy, and initially there is no kinetic energy, so the value would be 0. To find the kinetic energy of the spool itself, we can use the following equation: 1/2 times mass moment of inertia times angular velocity squared. And then we can also use the equation for kinetic energy, but for the hook, and we use 1/2 times mass times velocity squared. And this would give us our final kinetic energy when added together. So we would just simply plug in the information we have now for Ks, which is 1/2 times the mass moment of inertia, which we figured out we can find by multiplying the mass times the radius of gyration squared. And when we plug that in, we get 64.8 kilograms times meters per second times meters squared. And then we plug that into this equation. And then for angular velocity, we can change it to be in terms of velocity. Since we have the radius is equal to 1, we can simply plug in velocity over 1 for the angular velocity. And then kinetic energy for the spool, or Ks, would then be equal to 162 over 5 v squared. And then for kinetic energy of the hook, we can plug in the mass, which is 30 kilograms, and then we leave the velocity squared alone. So then Kh would then be equal to 15 velocity squared. And then when we add those two together, we get the final kinetic energy, which would be 237 over 5 velocity squared. And then moving on to the potential energy, the initial potential energy would also be 0. And to find the final potential energy, we can use the equation mass times gravity times change in distance. And when we plug that information in, we plug in 30 kilograms for the mass, 9.81 for the gravity, and for the change, it would be -3 meters, because it drops from rest down all the way down to 3 meters. And then for the final potential energy, we get that it is negative 882.9 joules. And so when we plug in what we have for into the conservation of energy equation, initial kinetic energy and potential kinetic energy will just end up being 0. And then final kinetic energy would be 237 over 5 times velocity squared, plus negative 882.9 for the final potential energy. And on this bottom right part, we can see the conservation of energy equation with all the values plugged in. And when we solve for velocity, we get that velocity is equal to 4.32 meters per second squared. And that gives us our final velocity and answer to the question.